Hello and welcome to the first LocoMotion Matching tutorial. LocoMotion Matching is a replicated locomotion system that I released to the Unreal Engine marketplace around a month ago. In this video, I'll be going through the necessary steps to replace the base animations that come with the system with your own animations for better customization. The grounded locomotion animations in the system were all generated using Motorica. Now, for those of you that don't know about Motorica or haven't heard about them before, they're a company that has a tool which allows users to use a generative AI model to synthesize mocap data, saving time and ultimately giving better results than a lot of, say, smaller indie developers would be able to gain access to. The model itself is trained on high quality mocap data that's captured by real mocap artists, or real mocap actors, sorry. So the input data is very high quality and the results often end up being quite impressive. So before we get into that, I'm just gonna open up the project. So this is a fresh installation of LocoMotion Matching as you get it from the marketplace. Nothing's been done to it. All the files are, in this folder as you would see. And let's say now I have, this version of the character that has male locomotion. It was generated. All the animations were generated using the male preset on Motorica. So this is, you could say, a male character, and it might look a bit odd on a female character, for example. So what we want to do now is use the system, use all the animation databases, the setups and etc., but just plug in our female animations and see how it works. So if we wanted to do that, the first thing that we would do is go to motorica.ai, and click this button. Oh, you can't see it right now. Click this button here, try online, and this will take you to the, I'm not really sure what this is called, but it's like the studio, call it. Before that, you would have had to sign in, but I'm already signed in here. So yeah. And before we continue, full disclosure, I do work for Motorica. I didn't when I made the system initially, but now I do. They're not paying me to make this video. It's not like a paid placement or anything like that, but I'm just showing how to use Motorica to generate animations for the system, because the base animations from the system were generated using Motorica. So it's quite intuitive to put the new animations in when it's from the same source. So yeah, I should probably keep the camera in the top left. So let's get started, right? So the basic components of your animation system, let's start just with rotation that follows the movement. So not strafing, just running direction. So if you look at the motion database that we'll be putting our animations into, or essentially replacing, you can see what components makes up the motion for a non-strafing running movement. And there are really three key components. There's the running straight animation, which is literally just the character running in a straight line. There's the arcs, which have various degrees of granularity. There's a bunch of different arcs. You've got your really tight arc and your really wide arc. And the reason we have all of these is because you kind of need this many arcs for a system that allows arcs, because if you don't, it will try and play a turning animation when you're meant to be arcing, and it doesn't really work very well. So we're going to need all of these in our new system. And then there's also the turns. And so here the turns aren't explicitly named turns. They're just in these animations. I think they're 1 through 10, which are essentially the character running, turning, so on and so forth. And I generated these using a Python script to generate the paths, and then plugged that Python script into the Motorica Studio plugin, which generated these animations. Now, I'm not going to share the script because it's not ready for release and it will end up just confusing a lot of people, so I'll just use the typical presets version, the presets way of generating animations with Motorica. So it's going to be a little bit different to the structure that you see here, but it will still work. So if we want to start generating these animations, the first thing we have to do is go to the Motorica website. Now, there's two ways of doing this. You can either do it here, generate the animations in this studio, and then download them into Unreal Engine, or you can head to motorica.com, and here under the Unreal Engine plugin section, you can see there's a whole tutorial on how to use the Motorica Studio plugin, and this is essentially a much quicker way of getting the animations into the engine, because you don't have to download them. They're just straight in there. So the first thing you need to do is download the plugin. you want the latest version, so we'll download the one for UE 5.4 because that's the version that LocoMotion Matching is on. So if we download this, then we will be presented with the link. We can download it here. And once this is done, we'll carry on. So once you've extracted the zip file, you'll then have this folder, the plugins folder. Go into that folder, go to Motorica Studio, and this is where the plugin is contained. So what we need to do is copy this plugins folder into our project. So if we quickly head to Unreal Projects and LocoMotion Matching tut, paste the folder into here, and you should probably close the engine before you do that. We've got the plugins folder, so we'll reopen the project now, and we will be presented with the Motorica Studio plugin already activated in the project. So when you open the project, you'll be greeted with this purple logo, and if we click this now, we're in the studio, the Motorica Studio, and the first thing you want to do is log in. Now the details and the setup for this is outlined in the documentation before you download the plugin. So I'm not going to go over that now, but you can, fill out your details in the project settings, click login, and you're in. And now we can choose between all of these different styles to generate animations for. So this is essentially the same setup that you'll find in here. So just because it's easier to show it here, let's say we want to generate a straight animation at speed 3.2, I believe is what we use for the project. Somewhere between 3 and 3.5, and target speed of 3.2 as well. In fact, no, we'll use constant speed, 3.2. So this preset will just make the character run at a constant speed, 3.2 meters per second for duration of 4 seconds. We can set to whatever we want. We'll do a 5-second animation. And in the style that we want, the style is very important. So we use male. The LocoMotion Matching uses male as the default set, the default style. Now, we said we wanted to generate some female animations, so we can untick male, tick female, click generate, and you'll see you will, after a short wait, be greeted with some new animations. Now, you can choose whatever preset you want here, right? You can choose injured, let's say, generate the animations and you'll get an injured animation. Or if you want something funky, you can go for like a zombie, I guess. The zombie preset's quite good, if I can get there. Zombie, you can also mix the styles, but for this tutorial we'll just be using a style on its own. But we can generate the animation for a zombie and you'll get a zombie. So choose whatever style you want. It's easy to preview them in here before you go into the Unreal Engine plugin. But as we said, we wanted female, right? So we'll just go female, no zombie, generate. And that's the preset we're going to be using. So if we head back into Unreal Engine, we can search for the same preset or just look for it. It will be female, that's the preset we want, 100%. And the first thing you want to do is click Add Actor. So this adds a dummy Motorica actor into the scene, which will have the animation applied to it. Now on the right side here, you can see a few things. You've got the seed, which is, the seed like there, it's just a number. If you use the same seed and generate an animation with the same parameters, it will give you the same animation every time. So once you find the seed, it's nice to use the same seed when you're generating your home motion database because they'll all be similar animations. The way that you get different animations by changing the seed. Now, you want to switch it from automatic to manual control mode because then you get to keep the seed. This button just generates a random seed, however you want to do it, and then these aren't necessary. Click generate animation, and after a short wait, you'll be presented with the animation. I see, oh, yes, we're in keyframe mode right now. So this means that you can add keyframes and choose what path you want your character to run at. We don't want to do that. We just want to use the presets like you saw on the website. So we'll use preset mode. We'll choose the preset type of constant speed like we did on the website. Forward, 3.2 meters per second. We're in the female mode. Manual, whatever seed you want, generate the animation. And here we have an animation. And it works, it's great, it's here. Now, the issue is, how do we get this into our project? So it's quite simple. Click Save Animation As, if we expand this. So yeah, Save Animation As. Do we do a separate folder here? Yeah, why not? Tutorial, I can't type, content. And we will create a new folder, animations. Go into this, say running. So these are where we're going to place all our animations. What I like to do at this point is now, okay, so let's save this as run forward. Just a simple name. Save it here. What I like to do to make this process a bit easier is, you see the folder that you created, animations running, add this to your favorites. Then it's a lot quicker to access it when you want to save animations. So, like I said earlier, the components to the motion database are runs, just straight running, turns, arcs, and I forgot to say stops and starts. So we've generated one running forward animation. We'll assume that's enough for now, but we might want more in the future, but just, we'll use a minimal set right now. Now we want to create a start and a stop. So for these, you want to use the straight preset. Speed is the speed that will be the speed at the start of the animation. Target speed will be the end of the animation. So if we have speed as 0, target speed 3.2, and we hit generate with the same seed, so we get similar animation to what we just generated, we will now, give it a second. Oh, there we go. I forgot to click it, I think. So it's an animation that starts in a stationary position and then starts running. So this is our start animation, and we can have multiple if we want, but again, we'll just do minimal set, only one. Save animation as, go into favorites, running, run forward, start. And you know what, we'll rename this one to run forward straight, just to make it a bit easier. Oh my days, I cannot type. Yeah, run forward straight. This one, we now want to stop, so we'll reverse it. We'll go 3.220, which means we'll be running at the start and then stop running. So this will be our stop animation. Brilliant. Favorites, running, run forward, stop. Now we want to deal with our arcs. So the way you do this is circle. So you set your speed, we'll set it to 3.2 again, and we set our turn rate. So we want to generate animations at increments of 30 degrees every one. So we'll have a 30, a 60, a 90, a 120, a 150, a 180. And that should be enough. I think that's enough. Also, sorry if my chair is creaking. It's a new chair. Well, yeah, it's terrible. 30 degrees per second is our first animation. Now, what we can do is generate 30 and minus 30. So we'll be looping, we'll be arcing to the right and arcing to the left. But what's a lot easier is if we just mirror the one to the right and it generates one to the left. That means we only have to generate half the amount of animations. So if we generate the animation here, we have an arc. It's a very shallow arc running at 3.2. Now 3.2 might be a bit slow. It might look a bit weird because I think I did use a higher value before, but let's just, for the sake of this, use 3.2. We'll see how it looks, and if you don't like how it looks, you can up your speed when you generate your animations. So we'll save this as run forward. You know what? I'm going to copy this to make it quicker. Run forward arc 30. We'll generate a 60, and we'll do the same thing. Now, I'm not gonna, sit here and make you watch me generate all these animations, so I'm gonna come back when I've generated all of them, but yeah. Okay, so now we have our arcs. I generated them up to 240, so 30 increments up to 240, so we've got 8 animations here. And we've got our start and our stop and our straight. We still need our turns, so we're gonna generate these now. And this will use the preset of, bear with me, I believe it's start turn 3.2. Let's say 90 degrees just to see what it looks like. And animation. Yeah, brilliant. So these are our turns. Now, they're not running turns, as in they're stationary and then a turn, but they'll still be used during the running turns because it will work. But yeah, so we want turns. We need a 90, we need a 180, we need a 45 is probably the lowest you should go. So we'll do 45, 90, 135, 180. I think that will suffice. And for this one, we do actually want to generate mirrored. So we want minus 45 and 45, minus 90, 90, so on and so forth, because I don't really like mirroring turns, but I like mirroring arcs. So we will generate that animation. This is a 45-degree turn. Brilliant. Yeah, we'll keep that. Save that as run forward turn 45L. And as you can probably guess, I'm going to generate the rest of them again off camera because you don't need to sit here and watch that. So I've generated all of those animations, and now we have our turns. So turn 135 L and R, 180 L and R, 45 L and R, 90 L and R. And you might think, what's the difference between 180L and 180R? 180L, the character turns to their left. 180R, the character turns to their right, which is quite important when you're blending different motions together. You need both options for the motion matching algorithm to pick through. So we've got our animations. It's a pretty limited data set. We could add more. You could add more turns, like 100-degree turn, 120-degree turn, so on and so forth, if you want to. And if you see issues with turns where you think that it's because there's not enough coverage, all you need to do, head into the plugin, generate the animations, and put them into the database. That's the beauty of using Motorica as a system. If you have issues and you see spots that are missing, it's so quick to just fill in the motion like that with the exact same parameters that you had before, same seeds and everything. So here we have our animations. Now, obviously, we need these on the Unreal Engine skeleton because, you know, I'm assuming that's what you want. So we will use the plugin. So the plugin has an inbuilt retargeter. If we go here, plugins, Motorica Studio Content, retargeting, Unreal Engine, UE5 Mannequin, it's here, RTG Mannequin, no. Yeah, RTG Mannequin Motorica. So this is Motorica to Mannequin. So this is the retargeter, and all of our animations that we just generated are prefixed with run FWD. So if you want to see any of them, we just search run FWD. We can now switch to, we'll switch to the Quinn skeleton for this actually, or the Quinn model, sorry. And yeah, we'll look for run FWD. Our animations are here, and they're retargeted onto the Unreal Mannequin, just like that. So to retarget all of them, Control A is the shortcut I just did there. Select them all and export the selected animations to our folder. Now we will create a new folder called Retargeted and save them in here. We should suffix them with UE5, export the files, and we have all of our lovely animations onto our Unreal Engine Mannequin skeleton. Now what you will want to do is, so this will retarget onto the Motorica Unreal skeleton. What we want is the LocoMotion Matching Unreal skeleton. Very simple, since they're the exact same skeleton, all you need to do is select all the animations, click replace skeleton, search LocoMotion, search Locomoti, and this is the skeleton, the SK Mannequin in the demo characters folder. That's our LocoMotion Matching skeleton. We do that and save, and now they're all onto the LocoMotion Matching skeleton. We can change the preview mesh to Quinn if we want to, like so, and it's the exact same thing. So now we've got our animations, we need to put them into the system. And as you may or may not know, LocoMotion Matching uses choosers to pick locomotion databases at runtime based on the current state of the character. So here we have our, in our animation folder, we have our choosers, we have post search, and if you head into the player one, not the AI one, we have our chooser here. Now this is just all the animation databases we have. These are the parameters. So what we want to do, we're using running, non-strafing. That's the animations we've just generated. So running here, I just changed that, whoops. Running, moving, running, velocity direction. That's the animation database that we are in question, the relevant one. So we can browse to it here, PSD running. This is the one we have. It's the one that I showed you earlier with all the arcs and stuff like that. So we want to create now a new one for our new animations. So what we can do here is we'll do it in the new folder just as a pure setup. So create a new folder, call this motion matching, and here we want to go to animation, motion matching, post search database. The schema we want to use is mocap schema running. Oh, I just clicked the wrong one. Whoops. Animation, motion matching, post search database. Yeah, mocap schema running, and we can name this new pose database. We'll just call it tutorial DB. So this motion database is where we're going to put our new animations, and to do that, all we have to do is, by the way, when I'm bringing up this drawer, I'm just control spacebar, sorry, and that just brings up the content drawer. We go to our new animations, retargeted, and they are all here. Now, there's a couple things you need to do to animations before you can use them for motion matching. First thing is, as you can see, this looks very wacky. It's because we haven't used root lock, so it's kind of doubling our root motion in every sense. So what we need to do is go to oops, where is it? Selection details. Yeah, go to the animation, select them all, right click, asset actions, edit selection in property matrix. Sorry, this allows you to edit the properties of the assets in bulk. We want to search for root. We want to force root lock and enable root motion. Save now, and the animations will look normal in the database. Their root motion is all good. So yeah, like I said earlier, the arcs, as we can see, they're all to the left. We need arcs to the right. We could have generated more arcs, but the easier way to do this is just, since we already have a mirror table set up in our schema, change the mirror option to original and mirrored, and voila, we have arcs to both sides. But I see I've not done that on bulk. Is there a way to do that on bulk? Yes. Okay, just, whoops. Just, yeah, double click that on each one. And we've now got our animations mirrored, sorry. All the arcs mirrored. It has a lovely flower pattern, whatever this is, and that's all the arcs we're going to need. I think that's actually more arcs than the base database. Then we have our start, we have our stop, we have our straight animation, and also, okay, so this animation doesn't loop, which might not be ideal. You can't generate looping animations in the plugin version of Motorica Studio, but you can on the website. So if you go to motion and you see the same preset, we use constant speed. It's a different seed, but don't worry about that. Duration's there. If we click loop now, we can generate looping animations. And this is quite important, actually, because for sustained periods of time, you do need looping. It worked in the base system because we had so much forward motion that it could kind of just pick different frames that blended together well. So there's no looping motion in the base system. But since we only have one forward loop, you probably will need a looping motion. We'll see how it looks without in the future though. And what you're going to want to do is set this to looping when in the base asset, if you do generate a looping one. But let's just, for argument's sake, say we're not using a looping one. This is our motion database, and you've got your turns here. So now let's work out how to put this into the system. First thing you want to do is in the motion database, the normalization set. It's important that you have this active. So will put these animations into the old normalization set. Basically what this does is it makes sure that all your different motion databases are linked with similar numbers and values, because if you have an idle database, for example, and then you have a motion database, the scores assigned to each one of the poses for the motion matching system will be quite different on the idle database than the motion database. So if you don't normalize them together, you'll get values of like 24,000 here and 0.03 here, and that's not going to work in a system. So you need to make sure those values are normalized, and when the system's comparing animations in its own data set, it's also looking at animations from other data sets that it might need to use if, say, we stop or we change to walking or whatever, and it takes those into account. So we have a normalization set, PSNS vel direction. Don't use the simplified one, simplified for AI. PSNS vel direction, use that as your normalization set. Now we need to double click this and go into the asset, and you can see that it has all the databases from the base system listed here. PSD running is the one we're replacing, so we'll change that to tutorial DB. So now the database is in the normalization set, and the normalization set is applied to the database. So that's brilliant. Now, another thing you want to do is, you see here, for performance reasons, on the AI characters, these are lowered. On the player characters, these are higher. What this does is it improves the search. It essentially just makes motion matching better, but at a cost of extra performance. Now, since our motion database is so small, and since this DB will be only used for player characters, we can afford to bump these values up. So by default, they're 4, 16, 200. We want to increase the number of principal components to 8 and bump this up to 250. This essentially means that it will be searching through more poses per frame, which again could have performance costs, but because there's so few animations, it's really negligible, and it just makes the quality better. So those are the changes you want to make. Oh, also preview mesh here, we could use Quinn as we were using before. So we'll change that. SKM Quinn. And this is our motion database now fully set up. So we're almost there. Now what we need to do is go into the chooser and make sure the chooser knows that we want to use this database instead of the one from the base. So PSD running should now be replaced. Again, I went over this earlier, but this is the one we want. PSD running, replace that with tutorial DB. And now this may look a bit strange because all the other motion is going to be from the base set, and just the running character motion is going to be from the new animation. But in theory, you would follow this same process for each one of these databases. And for your own system, you don't really need these transitions. So transitions and strafe transitions are custom databases that I set up, which essentially have animations that mix walking and running and stuff. You're going to need your run stop and your walk to run and run to walk. These are just for transitioning between gates. But again, this is a very simple tutorial that you can follow for just one smaller subsection of the thing. And once you understand how to replace some of the animations, it's quite intuitive to understand how to replace the rest of them. So that's why this tutorial will be an hour long if I did everything here. So yeah, we're ready to test. Well, we're almost ready to test. One more thing we need to do is make sure that the animations have the right information for foot locking. So foot locking is it's an experimental method that is used in Lyra, but it's what I use here to prevent foot sliding. So if you can, in fact, we'll go back to the base system quickly. So yeah, if you go into here now, you will see, what's the button for debug again? On controller, it is select. So you see these red circles. I can't really show them out to you, but the red circles on the feet show the status of the foot locking. Right now, the feet are locked and they're not going to slide. You can see they go from red to green. Green means they're unlocked, red means they're locked. And that's basically how we stop foot sliding from happening in the project, because when you're transitioning between animations and you're going through a lot of different states, it's very prone to foot sliding. So we need to make sure that these new animations have the correct information to feed into this system. And it's very simple to do that because I set up some in the base system. If we go into blueprints and in modifiers, you can see footlock 1 and footlock 2. It's a two-step process to make sure that any animation you have, running animation, will have the correct curves and notifiers applied to it. Not just for foot locking, but also for footsteps and footstep sounds. So if we go to our animation database tutorial DB, all these animations need those anim modifiers applied to them. We can browse to the content, highlight all the animations in the folder, right click, animation modifiers, add modifiers, and you need to do it in the order footlock 1, then footlock 2, because if it's 2 then 1 it's not going to work. So that's the order you need to do it in. Apply, it will take a little bit, and then bang, all the animations have the correct footlocking curves and footstep notifiers. It's just a simple system. So now that's ready, we can finally put the system together. So let's go back here, change our running back to tutorial DB, and let's test. And this is the result. We have our character. I've changed to the Quinn model for the showcase, but you can see it now has the new animations in the set. Maybe I generated the animations with a bit too slow of a speed, so I probably should have bumped it up to like 3.5 or so. But you can see that, you know, start, stops, stop, start, stop, start. Now the weird artifacts with the hands are because of the seed I used. I think some of the seeds with the female preset do have some strange hands and whatnot. So it's down to finding the right seed and finding the right motions and whatnot. But yeah, this is how you would add your own animations into LocoMotion Matching. So the next step for you would be to do the same thing for strafe or for walking or for idols, or you know, so on and so forth, and essentially replace the whole system with whatever preset you want. You can use a zombie preset, goblin preset, werewolf preset, whatever presets you want from Motorica, but as long as you keep the structure the same and generate the same animations with the same speeds, it doesn't matter what preset you use, it's going to work with the motion matching system. So hopefully that was useful. If there was anything that was unclear, then leave a comment and I can answer it, or you can join the Discord. Go to the project page, the LocoMotion Matching page on the Unreal Engine Marketplace, join the Discord, shoot me a message over there, and I'll get back to you quickly, hopefully, so I can help you with those kind of issues. If you did enjoy the video, make sure to like and subscribe, because there's going to be more tutorial content for LocoMotion Matching coming out soon. And yeah, that's all. Bye.